Our modern world hinges on space assets, unseen digital infrastructure powering everything from finance to global military operations.
The ground control station, a vital link, sends and receives commands across immense, silent cosmic distance.
Thousands of satellites orbit silently, serving as the eyes, ears, and navigators for every global military and commercial enterprise.
But this intricate network has a shadow: cyber warfare. It's the new frontier of global military conflict.
An invisible enemy targets the communication link, the digital lifeline between ground control and orbital assets.
Unlike kinetic attacks, this is silent sabotage. It's disruption without destruction, confusing the system, not shattering it physically.
State-sponsored actors, or skilled lone wolves, seek to exploit simple vulnerabilities for maximum global effect and disruption.
By corrupting the attitude control system, a satellite can be subtly turned off target, effectively blinding its mission.
When data is corrupted or delayed, the military's strategic advantage vanishes, leaving troops vulnerable and exposed.
A zombie satellite is the consequence: drifting, unresponsive, but still a dangerous piece of space debris and risk.
Tracing the attack back to its source is immensely challenging, hiding the perpetrator within the complex layers of the internet.
The biggest vulnerability often resides right here on Earth, the ground stations, which are susceptible to standard IT network intrusions.
Simple malware, initially targeting a payroll server, can ultimately compromise a nation's ability to command and control satellites.
Space cyber warfare is the great equalizer. A small group can inflict damage previously reserved only for global superpowers.
Without reliable, synchronized data, high-frequency trading halts instantly, leading to financial instability and market turmoil.
Power grids rely on accurate satellite timing for synchronization. Disruption could cause cascading blackouts across massive geographic regions.
The vulnerability begins long before launch, hidden within the complex international supply chain that builds the satellite components.
A compromised chip, a tiny backdoor, can be inserted during manufacturing, creating a delayed, catastrophic remote access point.
Once activated, the dormant vulnerability is a Trojan horse, suddenly seizing control of the satellite's core operating functions.
Defenders race against time, attempting to patch and isolate the compromised satellite system before complete digital takeover is achieved.
The strategy is defense in depth. Multiple overlapping security layers protecting the satellite, the data link, and the ground station itself.
Strong cryptographic protocols secure the command uplink, ensuring only authorized, authenticated commands can ever reach the asset.
International law struggles to define a cyber attack in space. When does sabotage cross the line into an act of war?
Global military powers must now collaborate to establish clear, enforceable rules and shared security norms for the orbital domain.
Future satellites are being engineered with resilience, capable of self-healing, detecting anomalies, and autonomously defending against cyber threats.
Vigilance is our best defense. Early detection, rapid response, and constant adaptation are the keys to maintaining orbit security.
Cyber warfare targeting space is not a future threat. It is happening now, and the stakes for all global military forces are profound.
The invisible battlefield is above us. The silent sabotage continues.
The first major vector is the uplink, the command signal sent from the ground station to the orbiting satellite itself.
Jamming is a basic denial-of-service attack, flooding the frequency with noise, effectively deafening the satellite to its rightful master.
The equipment for effective jamming is surprisingly mobile and accessible, making it an attractive, low-cost weapon for non-state adversaries. Spoofing is more insidious, convincing the satellite a malicious, false command signal is actually the legitimate, authorized one.
A spoofed deorbit command could send a multi-billion-dollar asset tumbling, a total loss, or even risk space debris generation.
Key defense is mutual authentication, ensuring both the satellite and the ground station can verify each other's digital identity.
Beyond the link, the satellite's onboard computer, its digital brain, is a prime target for deep-level software exploitation.
Flaws in flight software, like ancient code vulnerabilities, create a hidden access point for sophisticated, persistent digital attackers.
An attack can exploit memory management flaws, tricking the satellite into running hostile, unauthorized, malicious code that takes over.
Many operational satellites use legacy code designed decades ago without modern security considerations built in. They are digital time bombs.
Crisis protocols initiate immediately. The team attempts to wrest control back, sending override codes before the satellite is lost forever.
Modern defenses employ anomaly detection, recognizing the subtle digital fingerprint of an attack before it can successfully execute its payload.
The barrier to entry for space cyber attack is falling. Non-state actors now pose a credible, unpredictable threat to vital infrastructure.
Our everyday lives, from banking to emergency services, rely implicitly on the silent, secure functionality of these orbital systems.
Successful defense requires relentless patching, monitoring, and anticipating the adversary's next move against this high-value domain.
Developing a new generation of space cyber specialists is paramount. The human factor remains the most crucial defense barrier.
The protection of space is a global responsibility, demanding an international framework to manage the risks inherent in this shared domain.
Even deep space probes and scientific missions are now potential cyber targets, extending the battlefield far beyond Earth's immediate orbit.
The silent war for space supremacy is waged daily in the data streams. Understanding the vectors is the first step toward enduring global security.
We now shift our focus to the terrestrial segment, often the least secure part of the entire global military space architecture.
These massive, high-value ground stations are protected physically, yet their digital defenses are often inherited.
Simple, targeted spearphishing campaigns can bypass the external firewall, gaining a foothold inside the station's mission-critical networks.
The most sophisticated system is only as strong as its weakest human link. A moment of distraction can unlock the entire network.
Once inside, the adversary moves laterally, silently escalating privileges until they reach the most sensitive satellite command and control systems.
The final objective is the TT&C system, the digital key that allows direct,
The use of commercial, off-the-shelf components, while cost-effective, introduces known vulnerabilities into highly classified space systems.
A zero-trust model is essential, assuming every network request is hostile until it is verified, regardless of location or privilege.
Strong network segmentation contains any breach, preventing an intruder who gains a foothold from moving into mission-critical zones.
Protecting the ground segment is the new front line. Resilient, multi-layered defense is no longer optional for global military forces.
History provides clear warnings. Major satellite system hacks have already occurred, proving this threat is fully operational and active.
Early attacks often focused on espionage, silently extracting sensitive data and intelligence without the target knowing for weeks.
The 2022 Viasat attack, linked to geopolitical conflict, demonstrated how terrestrial war instantly spills over into the space domain.
Malware, a complex wiper, was specifically designed not just to disrupt, but to render the user terminals permanently useless.
The clear lesson is this: any major terrestrial military conflict will now inevitably involve a sophisticated
Military forces must train constantly in simulated cyber attacks, developing muscle memory for rapid, decisive mitigation under pressure.
Specialized red teams are hired to actively find vulnerabilities, pushing the limits of system defense before a real adversary ever can.
Real-time threat intelligence sharing among allied nations is crucial to build collective, resilient defenses against shared cyber adversaries.
The rise of massive LEO constellations creates a vast, new, and attractive digital attack surface for any hostile entity to exploit.
A coordinated attack on a single constellation could wipe out vital communications for an entire military theater or massive region.
Defense lies in distribution. If one satellite is compromised, the network quickly hands off the mission to dozens of other systems.
Automated, highly secure software patching is essential, ensuring the entire constellation can be updated and hardened against newly discovered zero-day exploits.
As space and terrestrial networks converge, a cyber attack starting on a 5G network could potentially hop into and compromise the orbiting satellites.
The defense of space is now inseparable from the defense of Earth's critical digital infrastructure. The fight is...
The silent killer can be heat. An attack on a satellite's thermal regulation system is a path to catastrophic hardware failure.
By manipulating heaters and cooling fans, an adversary can bake or freeze mission-critical electronics, resulting in irreparable physical damage.
This is the ultimate sabotage, a digital attack that causes a delayed, attributable, and utterly physical...
Continuous monitoring of non-mission critical telemetry, like voltage and temperature, can often detect the subtle signature of this silent sabotage.
The physical failure is irreversible, appearing as equipment malfunction when, in reality...
Satellites are designed for lifespans of 15 years or more, meaning security defenses must constantly evolve against unknown future threats.
Secure, authenticated over-the-air firmware updates are the only way to adapt defenses, ensuring the system can patch against new vulnerabilities.
Operational security surrounding update procedures is paramount. A compromised patch server is an open door for complete digital takeover.
Commercial space industry and government agencies must share standardized security frameworks and threat intelligence to achieve collective resilience.
Future systems will feature true onboard autonomy, capable of detecting and mitigating cyber anomalies before ground control can even be alerted.
Silent sabotage demands a persistent, evolving, and global defense posture. Complacency in space cybersecurity is absolutely not an option.
The constant, rapid evolution of the FFLUDA exploits means that tomorrow's threat is already...
Cyber effects on space assets fall into a spectrum, from denying simple access to the catastrophic, non-kinetic destruction of the satellite itself.
A brief denial of service attack can blind a reconnaissance mission, costing the global military precious hours of critical intelligence gathering capability.
Degradation is subtle but effective, slowing down the transmission, introducing errors, rendering critical real-time battlefield data unusable.
Disruption confuses the system. Conflicting commands make the satellite unable to determine its proper state, putting it into an unrecoverable loop.
Ultimate non-kinetic destruction, a command that silently disables all power and navigation systems, condemning the asset to burn up.
The doctrine of response is complex. How does a global military respond proportionally to a silent, non-attributable attack from the digital realm?
Miscalculation in the cyber domain can lead to rapid escalation, pushing a localized digital conflict quickly into a full-scale, devastating physical war.
Zero trust at every interface, at implementing case in both space and ground segments.
Custom, proprietary security protocols, not commercial software, are often required to protect highly sensitive, unique mission operating systems.
From simple denial to irreversible destruction, the goal of space cyber warfare is to disable global military and economic advantage. The space supply chain is a global spider web. Every vendor, every component, every line of code is a potential attack vector.
A tiny, malicious chip inserted during assembly is a nearly undetectable flaw, waiting years for the remote activation command.
In an international market, global military organizations must operate with extreme caution, practicing continuous
Specialized forensics teams perform deep hardware reverse engineering, meticulously searching for the subtle, physical signs of a deliberate digital compromise.
A cyber-induced explosion or uncontrolled deorbit event could trigger Kessler syndrome.
The catastrophic chain reaction. A cyber-shattered satellite creates thousands of high-velocity fragments, multiplying the kinetic threat instantly.
Space situational awareness becomes a vital necessity, tracking and predicting the trajectory of every dangerous fragment.
Avoidance maneuvers consume precious fuel, significantly shortening the operational lifespan of the satellite, an expensive consequence of debris creation.
The unseen cyber war holds the power to physically pollute and permanently close the
gates. The distinction between civilian and military space assets is dissolving. Global military forces in
commercial systems built for cost and speed often have lower security requirements than military dedicated assets, creating a major vulnerability.
Adversaries island hop, exploiting a weak commercial link to ultimately compromise the sensitive data and communications of an interconnected military client.
Military contracts now demand stringent, audited cybersecurity standards from all commercial space vendors, ensuring a baseline level of protection.
Constant, aggressive vulnerability scanning and penetration testing are applied to all third-party commercial software before it is allowed onto mission networks.
AI and machine learning will be used to automate cyber attacks, finding vulnerabilities faster than human teams can ever hope to patch them.
An AI adversary can rapidly evolve its attack methodology in real time. The only viable countermeasure is defensive AI, capable of detecting and mitigating automated attacks autonomously.
This is the ultimate arms race, an autonomous, continuous digital battle waged by sophisticated artificial intelligence for control of critical orbital assets.
The future of space cybersecurity is an AI versus AI war, where human oversight provides strategic direction, but not battlefield control.
Global financial markets depend on GPS and satellite time for transaction synchronization. An attack on these services brings
even a few millitiming drift compromises transaction integrity.
Consumer banking, automated teller machines, and international payment systems would fail, freezing capital and causing widespread public panic globally.
Position, navigation, and timing is the hidden bedrock of the global economy, and we need hardened, non-space-based backup systems immediately.
Terrestrial alternatives, like underground atomic clock networks, are being developed as a resilient backup against targeted GPS/timing cyber sabotage.
Cyber and electronic warfare are merging. Digital attacks can now be used to enable or enhance traditional jamming and radio frequency exploitation.
Malware can take over an adversary's own electronic warfare asset, turning it into a powerful, uncontrollable, and highly unpredictable weapon.
Defense must be unified. Cyber and electronic warfare strategies must be integrated to protect both the digital systems and the crucial radio frequencies. Advanced anti-jamming techniques like rapidly hopping frequencies ensure communications can survive intense, targeted electronic warfare attacks.
Corruption of data at rest on the satellite's solid-state drives is a form of sabotage that can persist, causing long-term, subtle mission failure.
A targeted, slow-burn attack can subtly alter calibration files or orbital parameters, leading to
continuous data hashing and integrity checks are required. Every single file on board must be digitally verified against its known, authorized state.
Immutable logging ensures that even if the system is compromised, investigators can forensically piece together the attacker's actions and digital footprint exactly.
Corrupted reconnaissance imagery can lead to disastrous tactical errors, costing lives and causing significant global military mission failure on the battlefield.
It does relations. The complex problem is policy. Applying international law drafted for physical war.
Does simply disrupting satellite communications meet the UN Charter's threshold for the use of force, or is it merely espionage?
New international norms of behavior must be negotiated and agreed upon, clearly outlining prohibited actions in the critical, shared domain of outer space.
The goal is to establish clear rules of the road, defining what constitutes.
The law must catch up to the technology. International agreements are urgently needed to prevent an
primary defense is unbreakable encryption, protecting the data in transit and ensuring the command authority cannot be spoofed or compromised easily.
Future-proofing security requires post-quantum cryptography, anticipating the computational power that could break today's standard encryption methods in the future. Frequent key rotation limits the time an attacker has to break the code. Even if a key is compromised, it is quickly rendered obsolete and useless.
Manual key management is highly susceptible to human error or insider threat. Automated machine-to-machine systems are the most secure defense.
The integrity of battlefield intelligence, command, and control hinges entirely on the unbroken, uncompromised integrity of the cryptographic layer.
The rise of LEO satellite mega constellations is changing the defense strategy. The sheer number of targets presents.
The mesh network utilizes inter-satellite links. A successful attack on one node is quickly bypassed.
The network that will instantly isolate the code. Engineers continually stress test the network, deliberately simulating multiple simultaneous failures to guarantee the system's mission-critical resilience under attack.
Deep within the satellite, the internal communication protocols, the internal nervous system, are often unsecured, a legacy vulnerability left in the open.
Once inside, the malicious code can silently inject false data directly onto the... Older internal bus protocols were not designed with security in mind. Retrofitting modern authentication onto them presents a tremendous, costly engineering challenge.
Hardware-enforced separation, physically isolating critical functions, is the final safeguard against any successful deep-level software compromise or digital attack.
The ultimate result of an internal bus attack is the complete, silent disabling of the mission-critical payload, the reason the satellite was launched.
Deterrence is the next frontier. Convincing adversaries the cost of a space cyber attack outweighs any potential tactical gain or strategic advantage.
Response options range from a proportional cyber counterattack to kinetic retaliation, a perilous, tightly controlled escalation ladder and scenario.
Explicitly demonstrating robust cyber defense and the credible capability for a retaliatory counterstrike.
The black box problem of attribution means a miscalculated, non-attributed attack could lead to a massive and highly destabilizing global military over-response.
Securing the internal nervous system and establishing clear lines of cyber deterrence are vital for preventing.
Security must be integrated from the very start. Security by design is the principle. Building defense into the architecture, not trying to bolt it on later.
Rigorous, continuous security auditing of all flight software code is a necessity, catching subtle flaws before they are ever launched into orbit.
The entire digital pipeline, from developer workstation to final upload, must be a cryptographically verified and fully protected chain of custody.
Formal methods using mathematical verification to prove code correctness eliminate entire classes of dangerous programming flaws before they are exploited.
Security is not just a technical challenge, it is a command responsibility, requiring leaders to accept and mitigate any and all identified residual risk.
The dark web has a booming marketplace for zero-day vulnerabilities, with massive bounties offered for exploits targeting high-value space and military assets.
The high financial incentive ensures a constant, sophisticated stream of new, targeted exploits are being developed and sold to state-level adversaries. Threat intelligence teams work constantly to penetrate these dark markets, attempting to purchase or track the exploit before an adversary can weaponize it.
Extensive bug bounty programs, paying ethical hackers to find flaws first, turn the dark market's economic model against the aggressive adversaries.
The war is fought with code and capital. Turning the ethical defense is a critical and highly effective counter-strategy. Modern military forces rely heavily on satellite communications to command and control drones. A cyber attack on this link is a tactical disaster immediately.
Denial of the command link renders the asset useless, forcing a costly return or outright crash, putting troops and assets at severe tactical risk.
Losing the satellite link in a tactical combat zone means a total, immediate loss of awareness.
Tactical resilience demands multiple layers of communication, including line-of-sight radio and other non-satellite dependent, hardened backup systems.
Forensics teams meticulously analyze the spoofing signature, searching for the subtle, telltale digital markers that can reveal the sophisticated adversary.
Sirens. Many mission-critical ground stations are in remote, hostile environments. Their isolation complicates maintenance.
Physical maintenance and emergency cyber response at remote sites are extremely difficult, adding valuable time for an adversary's. New strategies involve flying in completely cyber-hardened, self-contained, fully encapsulated security modules to remotely update and replace vulnerable systems.
Remote access, while a necessity for maintenance, must be meticulously controlled with strict multi-factor authentication.
Tactical effectiveness hinges on satellite resilience, making the securing of all remote ground sites and all the critical
Intelligent. Future defense relies on a unified, global, space domain awareness, integrating kinetic tracking.
Onboard sensors can detect the subtle energy signatures of a jamming attempt, initiating automated countermeasures before the attack can fully execute its payload.
Integrating physical tracking with digital telemetry.
Digital twin, a perfect virtual copy of the satellite, allows defenders to simulate a suspected attack in seconds without risking the real-world asset.
Informed decisions are made with the digital twin, allowing the command to execute the optimal, validated counter-response in critical, high-pressure moments.
Transcription. A transcription for the provided 8-second video scene is, beyond military alliances, all spacefaring nations.
Even geopolitical rivals share a common interest, preventing catastrophic, unmanaged space debris.
Anonymized threat signature sharing allows all nations to patch common vulnerabilities, creating a collective, unified, and more...
Commercial space industry leaders, by adopting high standards, effectively set the de facto global baseline for secure, responsible operations in orbit.
The defense of space against silent sabotage is fundamentally a human challenge, demanding unprecedented levels.
And for units. The propulsion subsystem, the satellite's ability to move, is a high-value target. Control over the thrusters.
Early detection relies on flagging anomalous telemetry. A sudden, unexpected fuel consumption rate.
Onboard, isolated logic must validate all thruster commands against preset, safe parameters. Only ground control can override a suspicion.
Defending space within a multinational global military alliance requires complex, secure, and shared command and control. Coordinated, multinational cyber defense drills are essential. A delayed response due to bureaucratical...
Secure, encrypted channels must be established for real-time threat intelligence, respecting each nation's security.
The entire alliance is only as cyber secure as its most vulnerable partner, a concerted effort to raise...
Propulsion security and multinational defense coordination are non-negotiable elements in the silent, persistent global military space cyber warfare campaign.
Software-defined satellites, SDS, offer immense flexibility, but their reconfigurable nature creates a constantly
malicious scuttling change quickly turning a communication relay. Verifying the security of dynamic, reconfigurable software is immensely complex, demanding new tools to track and validate every...
A cryptographically signed golden image allows for rapid, secure, and complete restoration of the satellite's core software to a known, trusted state.
In the event of a suspect compromise, the satellite's internal security logically triggers a full, safe, and...
Military doctrine has shifted from space as a sanctuary to space as a contested domain, requiring new defensive...
Active cyber defense involves aggressively identifying and disrupting the adversary's ground-based infrastructure before they can launch a successful orbital attack.
While tactically valuable, is highly perilous and fraught with significant legal...
Ethical considerations demand strict rules of engagement, ensuring that any cyber counteraction does not lead to
dynamic defense of software-defined satellites, and the complex, assertive doctrine of active cyber deterrence.
Atmospheric effects like heavy weather can disrupt the communications link of attack. A cyber exploit this natural noise.
Predictive modeling of solar activity and weather allows ground stations to pre-position defensive security measures before the natural masking noise arrives.
Radiation-hardened components are essential, protecting the satellite's electronics not only from solar flares, but also from...
The low-cost proliferation of CubeSats and small satellite networks introduces a significant volume of potentially...
Academic and startup space projects, often prioritizing function over security, can unintentionally introduce new and easily exploitable weaknesses into shared orbit.
A compromised CubeSat can be used as a digital stepping stone, approximate, secure, and authenticated.
The global military must insist on mandatory minimum cybersecurity standards for all orbital launches.
Defense must account for both environmental camouflage and the security risk of a small scale, lower cost, and easily...
The ultimate internal target is the core processor. Control over the CPU's firmware means total, unchallengeable, permanent control of the asset's function.
Hides in the processor's deepest layers.
Specialized hardware-assisted diagnostics are required to probe the deepest layers of the satellite's core firmware, searching for the subtle signs of a rootkit infection.
Even at the hardware level, the principle of least privilege must apply, ensuring no single component has unnecessary access to
the ultimate sabotage. A malicious research.
The immense skill required to defend space demands a dedicated, highly trained civilian and military reserve force.
Training must be continuous and realistic, utilizing live-fire cyber ranges and real-world attack scenarios to keep defenders on the absolute cutting edge of the domain.
This specialized reserve force is the nation's digital insurance policy, a rapid, expert response capability.
Governments must compete aggressively with the private sector for elite cyber talent, offering competitive incentives and...
The silent war is fought at the deepest levels of the hardware and software. The elite human expertise of our cyber reserve force is
The silent sabotage endangers not just global military security, but humanity's long-term vision of peaceful.
An attack on deep space communication relays could blind a crucial Mars mission, wasting billions in funding and years of dedicated human scientific effort.
The 1967 Outer Space Treaty must be urgently revisited and updated to explicitly include legal...
Only through binding, verifiable, and globally respected international agreements can we safeguard the orbital environment for all peaceful future endeavors.
Space is a shared utility for all humanity. Its protection is a collective imperative that transcends.
The financial cost of a major, successful space cyber attack would easily dwarf the current cost. The investment in hardening space systems is merely a fraction of the required to
Sustained, focused financial and human resource investment in advanced cyber defenses is the only responsible way forward for a globally connected future.
Our future in space, our global economy, and our collective security depend entirely on a committed...
Every facet of modern global military operation and civilian life, from finance to communication, is critically dependent.
The threat is multi-layered, from the compromised supply chain hardware to the ground station's insecure network and the satellite's vulnerable onboard firmware.
Indifference to space cyber defense is a direct invitation for catastrophic, non-kinetic attack. Global military leadership must act now without further delay.
Only unified, rapid, and multinational coordination can effectively and quickly counter a sophisticated...
The technological answer is clear. AI-driven anomaly detection, hardware-enforced isolation, and
Digital twins and constant red teaming allow us to simulate and defeat the attack in a virtual environment before it can ever threaten a live, high-value asset.
The distributed mesh network provides the critical resilience, instantly rerouting traffic around a compromised node.
The ultimate defense is human expertise, the tireless, focused skill of the cyber defenders who work constantly to protect
everything on Earth, from the precision of our modern surgery to the flow of all global trade, is constantly reliant.
The silent sabotage is a continuous, invisible war. But with dedicated action, this vital, shared domain of space...
Uplink spoofing is the silent command takeover. It tricks the satellite into accepting a malicious, unauthorized instruction, leading to complete control loss.
Malicious thruster commands quickly deplete precious fuel, ensuring the asset falls into an unrecoverable, pre-planned orbit and mission failure.
Every command must be mutually authenticated, verifying both the satellite and the ground station's true, cryptographically proven digital identity.
Rapid, proportional response protocols are essential for deterrence. The adversary must know that every single...
The ground segment, utilizing standard IT, remains the easiest vector. Lateral movement quickly leads an intruder to the final command and control server.
Successful timing attack on the ground system can instantly desynchronize the power grid, triggering widespread, massive cascading, critical electrical blackouts. Zero trust and strong network segmentation contain the breach, ensuring an intruder cannot move laterally from the back-office network to the main control system.
Rigorous, continuous vetting of all commercial off-the-shelf components is required. COTS software introduces known, easily exploitable security vulnerabilities.
Firmware rootkits represent the deepest, most persistent threat, surviving factory resets and giving the adversary permanent, low-level digital control.
A corrupted firmware instruction can permanently disable the mission payload, rendering the entire satellite useless, a multi-billion-dollar piece of debris.
Only specialized external hardware diagnostics can probe the deep layers of the core processor. Security must be mandatory from the concept phase.
Security by design is a fundamental command requirement for all new critical orbital military assets. A compromised component, a malicious chip inserted during manufacturing, creates a time-delayed.
A component can cause a catastrophic failure, triggering an unmanaged explosion.
Strict cryptographic verification of every single component's provenance is essential, ensuring the integrity of the supply chain from the original manufacturer to the final assembly.
An attack on PNT is an attack on the bedrock of modern life, collapsing the synchronization required for global finance.
Loss of accurate time synchronization immediately forces the shutdown of global high-frequency trading platforms, leading to immense and unprecedented economic instability and fear.
Terrestrial, non-space dependent atomic clock networks are essential to provide the necessary, resilient backup PNT.
Tactical resilience demands multiple, layered communication redundancy, ensuring that the loss of a satellite asset does not translate into a complete...
Subtly corrupting mission data, a slow burn attack alters calibration or orbital parameters, leading to gradual...
Corrupted reconnaissance data leads to disastrously flawed tactical and strategic decisions, directly risking the lives of the soldiers and mission failure. Continuous data hashing and cryptographic integrity checks are vital, ensuring every single file on the satellite is verified against its known, trusted state.
Defensive AI must be implemented to autonomously detect and mitigate attacks at machine speed.
The sheer volume of LEO satellites presents a massive, attractive attack surface. A coordinated simultaneous...
Resilience institutional defense, a fully distributed network isolates the failed node and instantly sorted out.
Investing now in robust space cyber defenses is exponentially cheaper than managing the cascading, catastrophic financial...
Future threats, autonomous AI-driven attacks, and quantum computing's decryption power demand that our current defenses...
Immediate migration to post-quantum cryptography is required, ensuring that future adversaries cannot simply harvest and decrypt.
Strict ethical and legal frameworks must govern the use of defensive and offensive of AI cyber capabilities.
The fundamental challenge remains attribution. Identifying the precise adversary behind a silent attack is difficult.
Misattributing hide attack could trigger a massive, disproportionate response.
Collaborative, real-time sharing of threat intelligence among global allies is the most effective tool to rapidly and reliably...
The security of space is a global responsibility. Every nation and every organization must act in concert.
We gaze upon Earth, protected by the delicate, unseen ballet of orbital technology.
The silent battlefield connects us all. Every digital command, every orbital decision dictate. The defense of our orbital assets is a continuous, relentless process, demanding vigilance, innovation.
We have recognized the silent threat, prepared the defenses, and committed the necessary resources. The stakes are civilization itself. The silent sabotage must be met with overwhelming, unified, and decisive.
The critical challenge, the solution is in place. We must maintain our vigilance and constantly adapt. Cyber warfare, the silent sabotage of space assets, acted global military. Credit roll 1. Executive producer, director, and lead research analyst names display smoothly on screen now.
Credit roll 2. Technical advisors, cybersecurity consultants, and visual effects team names display with gratitude for the critical support.
Credit roll 3. Music and sound design team, archival footage, and stock imagery providers now display for their valuable contribution to the entire project. Special thanks to all participating global military and international space research organizations for their essential guidance, data, and critical help.
This production was made possible by the generous support of viewers like you and all dedicated defense personnel around the world now. To explore for global security, space defense, and the future of cyber warfare.
The battle for the ultimate high ground continues in the digital shadows. Thank you for watching this critical presentation and documentary.